Determine the formal charge for each atom of a nitrite ion, NO2 with a -1 charge. First, we'll need to have a correct Lewis dot structure for this ion to work with, and we can see that that has a single and a double bond to the central nitrogen atom and a lone pair of electrons on the nitrogen atom. The formal charge on an atom in this ion or any other molecular ion is determined by the number of valence electrons that that element has minus a sum that includes the number of lone pair electrons and half of the bonding electrons. So we're going to take the number of valence electrons and subtract the lone pair electrons, and we're also subtracting half of the bonding electrons from that number of valence electrons. In this case, for the oxygen on the left of our structure, the formal charge will equal the number of valence electrons, which is 6 for oxygen, minus, we've got 3 lone pairs of electrons, which gives us a total of 6 lone pair electrons, plus half of the 2 bonding electrons that are shared between that oxygen and the nitrogen atom, giving us a formal charge of 6 minus 7, which is equal to -1. So the formal charge on the oxygen on the left is -1. For the nitrogen atom, the formal charge will be equal to the number of valence electrons for nitrogen, which is 5, minus the 2 lone pair electrons, a lone pair above the symbol for nitrogen in this structure, plus half of the 6 bonding electrons. We've got a single bond on the left and a double bond on the right. That's 6 electrons total. We're going to take half of that and add it to the number of lone pair electrons subtracted from the valence electrons. So we end up with 5 minus 5, giving us a formal charge for nitrogen, the central nitrogen atom. And for the oxygen atom on the right, the formal charge will equal the number of valence electrons, again 6 for oxygen, minus all of the lone pair electrons, and notice that there are 2 lone pairs of electrons on this oxygen atom, contributing 4 lone pair electrons altogether, plus half of the double bond, which is half of the 4 bonding electrons, giving us a formal charge of 6 minus 6, being equal to 0 for the oxygen atom on the right. So the final solution is formal charges of -1 for the oxygen on the left, 0 for the central nitrogen atom, and 0 for the oxygen on the right. And notice that if you add up all the formal charges for all the atoms in this particular ion, you end up with the charge on the ion, and that must always be true. If you were doing formal charges for a neutral molecule, you would end up with 0, because neutral molecules have 0 overall charge.